Hello, this is checkpoint 4.40 from section 4.8. They want us to take the limit as x approaches 0 of x times cotangent of x. And if we simply put in the values into these factors, x goes into 0 will give us a 0. Cotangent is 1 over tangent, and the tangent of 0 is 0, so 1 over 0 is going to be infinity. So here we have an indeterminate form. We know that 0 times anything is 0, provided that anything is not infinity, and infinity times infinity is infinity, provided that the thing is not 0. So this might be 0, might be infinity, but it might also be a finite number between 0 and infinity. So we should really take good care to try to figure out what this is equal to. All right, now our first step here is to rewrite it so that it's going to be a fraction, and then it would be of the form, when we take the limit, it would be of the form of 0 over 0 or infinity over infinity. So without taking L'Hopital's rule yet, we're just rewriting this. We'll take the limit as x approaches 0, and the best thing to do to make this into a fraction is we have already referred to the cotangent as a 1 over tangent. So if that's 1 over tangent, it would be a tangent in the denominator. And meanwhile, x would just be by itself up there. And so we can rewrite this x times cotangent of x as x divided by the tangent of x. Now, if we take the limit as it goes off to 0, we're going to get 0 in the numerator, and the tangent of 0 is 0. That's 0 in the denominator. And so now we have an indeterminate form. Because we have an indeterminate form, we will be allowed to apply L'Hopital's rule. And so this is going to equal to, conditionally, if the limit exists, this is going to equal to the limit as x approaches 0 of the derivative of each of the numerator and the denominator. And I think we've seen this in a previous checkpoint. The derivative of x is 1, and the derivative of tangent is secant squared of x. And since the 1 is just a 1, we know that this is not going to be indeterminate anymore, and we're just taking we're just finding out what happens at 0 for the secant function. Secant is 1 over cosine. Cosine of 0 is 1, so this is going to be 1. So the limit here is going to be equal to 1. Okay, and by the way, L'Hopital's equality will hold. Okay, that's it. Hope that helps.